The first thing to do with a quadratic inequality is to just treat it like as if it was a quadratic equality. Again, there's a lot of ways to do this, but the textbook says one way, I say the other way, yet another source would say another way. So I'll just do it my way. I believe the textbook does have this too, but it's not its first procedure, and I think this is actually much easier. So let's say we have an x squared plus 5x plus 6 equals, no, not equals, let's have a greater than or equal to 0, because we're doing inequalities. And this is a very simple quadratic inequality, one of the most simple. So what we do is we treat this inequality as if it was an equality, so just switch that greater than or equal to into an equal sign. So when we switch it, it's going to be x squared plus 5x plus 6 is, instead of greater than or equal to, we'll just treat it like it was an equality for now. So when you factor it, this is a very easy one. It should pop into your head right away that it's x plus 2 times x plus 3 equal to 0. And we even go as far as solving for x. So we set both x plus 2 equal to 0 and x plus 3 equal to 0, like so. So x would equal negative 2 and x would equal negative 3. Now, what we do is we have to make a number line like so. And what we're going to do is we're going to split the number line into 3 different sections. So this is going to be negative 2, this is negative 3. So as you can see, we have 3 sections here. 1, 2, and 3, right here. We have to pick a number from each of these 3 sections and test whether it is part of the solution or not. But before we do that, we have to test these negative 2, negative 3, we have to test these themselves into this original equation so that we know if they're open circles like that or they're filled in like that. And of course, common sense would tell you that it's, if we're dealing with greater than or equal to, these would be filled, and you would be right, but let's just plug them in because it's good practice. So we got that. It's common sense, but you know, just in case you don't know whether to put an open, a filled in, or an open, you can just do that. And now we have to pick one number from each. So in this case, I'll just go with a negative 5, I guess. Here I'll go with a negative 2.5, and here I'll go with 0, because 0 is a nice and easy, clean number. And wait a second, what am I doing here? And I did make a mistake here in the fact that I just like switched these two, but it is a brain malfunction, I guess. A negative 3 is definitely not greater than negative 2. But yeah, I just choose these 3 numbers to test. So we'll just go through each one. So for negative 5, we can just substitute negative 5 plus 2 and negative 5 plus 3 equal to 0. This is going to be a negative number. Oh, this is greater than or equal to 0, by the way. And this is also going to be a negative number, right? And a negative times a negative is a positive, so we know that no matter what, this is going to be true, because negative times negative is positive. Even if it's 0, it's still going to work. So we know that all of this is part of the solution right here. All of this stuff. So this is part of the solution. And now we can test the negative 2.5 here. Like that. And we can see that this is a negative number, but this is a positive number. So it's going to be a negative number. So no matter what, this has to not be true, because negative numbers can't be greater than or equal to 0. Now for the last one, we just plug in 0 here, so we get 0 plus 2 times 0 plus 3. That's a positive times a positive, which is always going to be positive, so this is also all part of our solution. Interesting thing to note that if sections 1 and if section 1 is part of the solution, then section 3 will also always be part of the solution, and section 2 will always not be. If only section 2 is part of the solution, then 1 and 3 will always not be part of the solution. So it's either 1 and 3 or just 2. So now we have our answer to our quadratic inequality. So let's just come up with this in set notation. So I guess we can call it a negative infinity, comma, negative 3, and then a bracket just to show that it includes it. And I guess we can do a union of that with negative 2, comma, positive infinity, like that. And that would be how you would express the solution in set notation. You remember this, right? In Algebra 1, kind of. Alright, let's just do a basic review. Let's just get rid of some of this here. Set notation, if it's like parentheses, it means it's the same thing as on a number line if you just made a open circle. If it's brackets like this, then it's the same thing as a shaded in circle. So if this is like negative 3 onwards, then you would have a negative 3 to, I don't know, whatever number you want. And this would be if this was negative 3, it would be a negative 3 positive infinity. So the infinity, the parentheses are telling you that it's not including the negative 3, and the brackets are telling you that it is, the solution does include negative 3. So that's just one quadratic inequality. I guess that's good enough for me, I guess. If you do want one more inequality or you just don't get it, you could always message me and I'll do another video, of course. Next video's review. See you then.